Good afternoon, everybody. The last time we've met, we've discussed some improvement strategies. Today, I'll give you my final bit of advice. Now, during any study session, I would like you from now onwards to focus on your book work, which are the marks that you're taking into the examination room. That means your definitions, your principles, the laws as they appear, remember, in your examination guideline. Don't forget. And remember that chemistry is a language, which means that you must also practice the correct terms like the position of equilibrium, etc., etc. Then after you've done all your book work, which you must study now, as from today onwards for your final exams, then tackle the numerical problems. Those are like the calculations and where you also have to do some explanations from past papers. You do this in a special book, in which you do all your calculations, your explanations, and you do your corrections as well, your notes and reminders to yourself not to forget about certain things. And you keep this little book until the day or two before the finals, and then you revise from the book, and you make sure that you go through it thoroughly the 2 or 3 days before the examinations. And the last piece of advice, please work through your question papers. I suggest that you do at least 8 question papers, 4 from paper 1, 4 paper 1 question papers, and 4 paper 2 question papers. So, let's see what we have up for today because we've got a jam-packed program for you. Let's go to my screen quickly. Today we are going to do one. We're going to look at 1 or 2 study tips, and then after that, we'll go to example number 1, and then secondly, we'll go through, under example 1, we'll do the problem-solving strategy as well as apply the strategy, and thereafter we do an activity number 6.1 in your book, and we do the problem-solving strategy, and we apply the strategy immediately after that. Now, are you ready? Because I haven't seen anybody logging in as yet. I would please like you to do that, and don't forget the number in the studio, the WhatsApp numbers, you've got that, they will appear shortly for you to see, but I would like you to really contact us today and ask questions because today's topic is one of those that is a perennial one. It always occurs in question papers. So let's see, what's the first piece of advice I have for you? One of the first things I want you to know and understand is that you must have a good understanding of the mole concept. That means you must know that the mole is a measuring unit invented by chemists, and that makes it quite easy for us to talk about large numbers like atoms, ions, and molecules. And of course, you also know that the mole is that coefficient that is in front of numbers, of our formula in our balanced equation. And you must know how to use the mole ratio. Number 2 on my screen is that you must know how to convert the volume and the concentration to moles. That's right, how to convert the volumes and the concentration to moles. And we would like you, in order to do that, that you actually really get into it. Today, though, I'm sure that if we try and do that, you will notice that this formula is the one that you really know. You know that formula very well, but let's see what we can do with it. Let's, for instance, let's say we want to take and we want to convert centimeter cube, we want to convert that into decimeter cube. Now, how do you do that? You simply divide by 1,000. But why is that so? That's the question. Let's see. We will suggest that you go to step number 1 and you write down how many centimeters is equal to 1 decimeter. That is what we want you to do. Then in step 2, you cube both sides of the equation, and then you simply apply it, and you get it right there. Let me see. That's right. 10 cubed, and then the centimeter cubed gives you 1,000 centimeters cubed, as well as 1 decimeter cube. Everybody there? I'm here now. So you take that 10 and you cube it, and you take the centimeter and you cube it as well, and then we cube the 1 and we cube the decimeter, and if we use our indices law, it's very simple. 3 cubed is then 1,000, and 1 cube is still 1, so 1,000 centimeters in 1 decimeter, and that's why we divide by 1,000 eventually. Now, I'm sure I haven't seen anybody logging in. I hope that there are learners out there who want to talk to us in the studio today. But let's look at the second piece of advice I have for you. The first one was, of course, how to convert from cubic centimeters to cubic decimeters. Second piece of advice, please remember that you must only approximate your final answer correct to 2 decimal places. What do I mean by that? I mean that your answer in the long run, at the end, after the decimal comma, you must convert or round off rather until you only have 2 numbers after the decimal comma. That's right. Let's quickly look at the second piece of advice. The second one says that you must not round off while you are doing your calculations except in the answer. Now, what is next? Next, we will come up with a problem-solving strategy which you can use if you want to calculate the percentage of purity of a substance. Now, what are those? Step one, that you must understand your problem and you must have a method. What do I mean by that? Simply that you need to find a numerator and a denominator and multiply it by 100%. Let's look at my screen again and we'll see it under step 1. Under step 1, we see that you must have a numerator and a denominator of a fraction and then multiply that by 100%. In step 2, whenever they give you another chemical which is a standard one that you know the concentration of and one that you know the volume of, please use this formula to get the number of moles. Once you've got the moles from your Barron's equation, find or reduce your ratio. Number 3, find then a simple proportion. Later on I'll show you what I mean by that. And lastly, take your moles and you make it into mass. And from the mass, once you have the mass, you take the one mass up there and divide it by the lower mass. You take the one mass at the top and you divide by the one that was given originally and you multiply that by 100%. Now, I know that sounds like a mouthful. It's not easy to understand, but let me show it to you differently. Let us go back to the screen. I'll show it to you differently. Let's say I take that away there and I have this chart for you. I say, point 1, understand what you want to do and have a plan to tackle the problem. Number 2, make sure you can use this formula. Number 3, step 3, make sure you have a balanced equation and you can see the ratio between what you know and what you want to find out. Number 3, sometimes we have to use simple proportion. In other words, I know one part, but I want to know what volume or what concentration will constitute 4 parts. In other words, I know one part, I want to find out, do I know the entire piece or 4 parts? That's proportion. Then I use this formula to get the mass, and lastly, I use that equation or formula up there to find the percentage purity. So those are the steps that we normally use. Now, I wonder, can you mention those steps to me quickly? What was the first step? Read through, and then understand, and make a plan, and say, this is my strategy, this is the way I'm going to do it. Number 2, they will always give you concentration and volume of something, and all you've got to do once you've got the concentration and the volume is you must calculate the number of moles. That's step number 2. Step number 3, I challenge you to remember, you must have a balanced equation. You can't do chemistry without a balanced equation. And then, of course, you must be able to read the mole ratio. So many moles of this one, so many moles of the other one. Number 4, you must be able, if you've got a small part, you must know how to reach the big part. That is called the simple proportion. That is a if-then statement. If I have one part, then how much would I need for 4 parts? Then once you've got the moles, the number of moles, easy peasy, you switch to mass. And last step, then I answer the question, what is the percentage purity? Just look at my screen one more time and you'll see it there on the side. There we go. There we have, understand it, use that formula, know your balance equation, know how to use proportion, and then of course make sure that you find the mass from the number of moles which you got from there, and then lastly make sure you know how to calculate percentage purity. Now, why am I mentioning this to you? Because if you study any paper since 2014, 2015 supplementary paper, 2015 final, 2016 supplementary paper, this kind of question is there. So maybe better listen up, because we might just need it at the end of the year. We never know.